We're going to the mean value theorem. But first I want to talk about roly-poly theorem. I want to talk about Rolle's theorem, what we did yesterday. What kind of conditions did Rolle's theorem have to do? First, they had to have the same y values. They had to have the same y values, right? And it had to be a continuous and what? Differentiable function. So I'm going to draw it without lifting my pencil and make it differentiable. And then what was happening? There had to be at least what? One time that the slope was 0. F prime of c was equal to 0. Now on this one, how many times did that happen? Twice. Right? Well, what was the slope between these 2 points? What is the slope between these 2 points? If the y values are the same, the slope is what? 0. And we found when the slope of the function was 0. But what if it's not 0? What if it's like that? So we could find the slope between the points and find when that is tangent to my curve. That's what the mean value theorem is. Let's do it. So here we go. The mean value theorem, MVT. This is what I need you to write. If f is continuous, so I need a continuous function. So it has to be continuous, and it has to be differentiable. So I need a continuous and differentiable function. Then, this is what I need you to write. F prime of c is equal to f of b minus f of a over b minus a. And we were really doing this same theorem yesterday, except every time we did it, the slope of the secant line was 0 every time. Now it's not going to be. All right? So I want to break this down for you a little bit more. I want to show you how many different ways we can say this. What does f prime of c mean? That's a derivative, right? And what's a derivative? Slope of a tangent line. So I'm going to call that slope of a tangent line, or calculus slope. Right? Now, what is this f of b minus f of a over b minus a? y2 minus y1 over x2 minus x1. What is that? That's algebra slope. So calculus slope is equal to algebra slope.
Yeah, that's really what you need to do here.
Very good.
That's
All right.
really what it's asking. That has.
So we need to figure out when those things are the same.
Yes.
So instantaneous rate of change is equal to average rate of change. Slope of the tangent line is equal to slope of the secant line. Calculus slope equal to algebra slope. All right, that is what mean value theorem is. Pretty nifty. At least how many times? One time, but the function has to be what? Continuous and differentiable. Okay? All right, let's into practice. Here we go. So I got this function. I have f of x is equal to 5 minus 4 over x. And I need to find all the values on the open interval of 1 to 4 such that f prime of c is equal to f of 4 minus f of 1 over 4 minus 1. So basically they're saying what? Use mean value theorem. That's what they're saying. Use mean value theorem. All right, so I need calculus slope and I need algebra slope. Let's do calculus slope. So to do calculus slope, I need to take a derivative. So what's the derivative of 5? 0. Then what's the derivative of negative 4 over x? Let's see how quickly we can do this now. It's not negative. It's what? 4 over x squared. Okay? Guys, if you still have to, go off to the side, say it's negative 4, x to the negative first, bring down the negative 1, subtract 1, right? Okay, but we've been doing that a while. You should be able to do that pretty quickly. So there's my algebra slope. And now I need to find what? Or that's my calculus slope, I'm sorry. So there's my calculus slope. Now I need to find my algebra slope. So I need to find f of 4 minus f of 1 over 4 minus 1. So what is f of 4? 4. Minus, what is f of 1? 1 over 4 minus 3. Sure. All right. So we end up with 1. So my algebra slope was equal to 1. Now yesterday, all the algebra slopes were equal to what? 0, because they were the same y values. Now it's 1 on this one. So guess what? Now we're going to set our calculus slope equal to algebra slope. So now I say 4 over x squared is equal to 1. Now I'm going to solve for x. So what do? We multiply by x squared. So 4 is equal to x squared. What does x equal? I square root it, right? X equals what? Positive or negative 2. All right. Actually, I want to just write 2 and then negative 2. Are both of those my solutions? Negative 2 is not my solution. Why, Becca? It's not on my interval. 2 is on my interval. Negative 2 is not on my interval. If it's not on my interval, do I care about it? No. Not at all. All right? And so what's happening here is I have that going on. Okay? I have the slope of my secant line, which would be equal to the slope of my tangent line at x equals 2. See how that worked? All right, and this is a very powerful theorem that we're going to be talking about for a little bit. All right, let's do it again. So on this one, we're going to find the equation of a tangent line. We're going to find the equation of the tangent line. What do we need for an equation of a tangent line? A what? Point and a slope. Man, we've been doing that for a while, and we're still going to do it for a while. Of the graph, f of x is equal to 2x plus sine x plus 1 on the interval 0 to pi at the point in which is the solution of the mean value theorem. All right? So, what's the mean value theorem? Algebra slope is equal to calculus slope. All right? So, let's take a derivative. Let's do the calculus slope. So what is f prime? What's the derivative of 2x? 2. What's the derivative of sine? Cosine. What's the derivative of 1? 0. So I got 2 plus cosine. That's my derivative. That's my calculus slope. Now I need to find slope of the algebra slope. So now I need to find f of pi minus f of 0 over pi minus 0. Good thing we know our unit circle. So now I substitute in pi. So 2 times pi is 2 pi. And then what is the sign of pi? 0. And then what's 1? It's just 1. All right. So I got 2 pi plus 1. Minus, now I'm going to substitute in 0. So 2 times 0 is 0. Sine of 0, 0. Plus 1 is 1. Pi minus 0. So what do I get up top? 2 pi over pi, which is 2. All right. So my algebra slope is 2. All right. So what do I need to do with those two things? Set them equal. So now I say 2 plus cosine x is equal to 2. All right. My calculus slope is equal to my algebra slope. So let's quickly solve for x. So I subtract 2, so I get cosine x equals 0. When does cosine give me 0? Pi over 2, and 3 pi over 2, and 5 pi over 2. But why do I not need all those? They're not on my interval. I want my interval 0 to pi. Yes? So there is the point at which, well, it's not the point yet. It's the x value at which I have a solution to mean value theorem. But it asks me for an equation of a tangent line. So I need a point and a slope. All right. Do I have a slope? Yes. What is my slope? 2. No, it's just 2. It is 2. All right. We got 2. We set them equal. That's what we solve for by the mean value theorem. So do I have a point, though? No. So let's substitute it back in. Which one do we substitute back in? The original. So 2 times pi over 2 is pi. plus, what is the sine of pi over 2? 1 plus 1. So my point is pi over 2 comma pi plus 2. So what's my equation of my tangent line? Y equals, what's my slope? 2 times x minus, what is the x value? Pi over 2. And then plus, what is the y value? Pi plus 2. All right. And so there is my equation of my tangent line. Now, I want you to graph it, okay? So what we're going to graph is we're going to graph this original function, and we're going to graph the slope of, or the tangent line. And I want you to set your window to 0 to pi, all right? So I want you to set your x values of your window from 0 to pi. On this, I just want to show you that the secant line, if I were to connect right here and here and make a line, all right? If I were to make a line, do you see how they run parallel to each other?
Yes.
All right?
Yes.
That's what the mean value theorem does. The slope of the secant line, that red line in this one, is equal to the slope of the tangent line. They will run parallel.
Wait a hot minute.
Okay? Hello.
You know that turns into
Two stationary patrol cars equipped with radar are 5 miles apart on the highway, as shown in Figure 3.14. As a truck passes
Truck.
Oh, truck. I can't see that far.
It's okay. It's a truck.
Yeah. As a truck passes the first patrol car, its speed is clocked at 55 miles per hour. 4 minutes later, when the truck passes the second patrol car, its speed is clocked at 50 miles per hour. Prove that the truck must have exceeded the speed limit of 55 miles per hour at some time during the 4 minutes.
All right. Now, we're going to use mean value theorem. What did the popo do? They shot him, right? But what kind of rate of change did they find? Instantaneous rate of change. They did the calculus slope, all right, or the little gun did. All right.
They don't know how to do that.
All right. So the little gun told them that they were going 50 miles per hour, and then they were going 55 miles per hour, right? So trucker did not pass the speed limit according to their little radar gun, right? However, what the mean value theorem says is that instantaneous rate of change is equal to the average rate of change at least what? One time. So what they could do is find the average rate of change. So S prime of t is really what the radar gun is doing, right? That's what the radar gun is doing. And that's equal to S of something minus S of the other thing over, right? But I want to find that. It's in 4 minutes. Now, we don't clock them in minutes, right? So I want to convert that to hours, all right? So I have 4 minutes over 60 minutes, right? And so what does that simplify to? 1 over 15, all right? And so it's really S of 1/15 minus S of 0 over 1/15 minus 0. Now, how far apart were these popo? 5 miles. So what is S of 1/15? What is my position at 1/15 of an hour? 5 miles. So I have S prime of t, which is equal to 5 minus, well, where did they start? At 0 over 1/15. So I have 5 over 1/15. Now, when you divide, you multiply by its reciprocal. So how fast was the average speed?
I know.
What you got?
75.
75. So the average speed of that trucker was 75 miles per hour. He's booking it. All right? But, you know, they get on their little radio. They're like, we got a copper here, mile 15. All right? Did they get caught? No. But if they knew the mean value theorem,
They gassed it.
how many times did they go 75 miles per hour? At least once. Now, if you think about it, they actually went at least twice. Because if your average was 75 and you got 50 and 55, didn't you actually get past 75 at some point and then get down to 75 at some point?
Accelerate and
So,
decelerate.
the trucker actually went 75 at least twice. Okay, if you think
Really
about it.
going over
But
it.
by the mean value theorem, it proves it at least what? One time. All right. Now, if the Polk Parkway ever catches on to this, we're in trouble. They have stations, right? You have to go through the station at 25 or 35 or whatever, right? But they're marked a certain distance. True? Could they not time your average rate? You already go through it and it scans your little
Nobody
your
got
little
time for
tag. Oh, that would be a simple program.
Yeah.
It really
And
would be.
It would be, but
But
Yeah,
think about it.
it
Think about
it
it.
could have.
Couldn't it clock you then
It could have.
and clock you then and do your average?
It could affect. It could very effectively catch.
Wouldn't your instantaneous rate of speed be at least that what?
Once.
One time, but really twice? Couldn't it? All right, don't tell them. All right. But that's what the mean value theorem is doing. All right. So we're doing mean value theorem on your block day. Actually, tomorrow we're going to do another circuit. All right. We're going to talk about IVT, EVT, and MVT all in one circuit. It's going to be jumbled up. All right. It's going to make your head hurt a little bit, but hopefully it will solidify it.